integrals of inverse trig functions. Trig functions. Okay, there are three of them, and I'll just list them and then we'll talk about them. Okay, so let's start by talking about this one. Here's the frustration. Obviously, in the homework tonight, you're going to be doing the problems that are set up to apply this. However, if you're just looking at general calc stuff, like we're preparing for the AP test, we're doing review, all that other stuff. A problem like this shows up, and you start trying to figure out how to do it. So we've been doing integral problems for quite a while. First thing you're going to do is look and see, well, is that a UDU problem? Okay, so let's make a squared minus u. A would, by the way, a is a constant, and u is some type of function, 2x, whatever it happens to be. Thank you, Jim. So you start deciding or trying to figure out how you're going to do that. You could do something like UDU, and then you get frustrated when you realize, well, things don't cancel. Okay, well, what if I try to simplify it? There's no ways to simplify it. My point being that these three little theorems pop up every once in a while, and you're probably not going to recognize them as inverse trig functions. But you will recognize them as something that you could probably solve, and that's what's going to cause the issues here, is getting them to fit into something that you wouldn't think of being an inverse trig function. Did any of that make sense? Okay, I'll show you when we do it. I got a couple examples for you, and I'll rattle those off for you. And all three of them are just close enough to make it frustrating. Okay, we good? You got all three? Good? Okay. If not, we'll come back to it in a second. Okay, sidebar. Before we get into this problem, let me talk about some things I see repeatedly, and maybe this will help you. What's the derivative of 4x squared? 8x. Any problems with that? Okay. Now, what I'm seeing some of you do is not incorrect. It's just making your life a lot more difficult. For instance, what did I just do? Product rule. Okay. Is that wrong? No, because 0 times x squared is 0, and 4 times 2x is 8x. Same thing happens when you're doing, let's say, the derivative of this. How would you do that derivative? Yeah, it should be 4 times x to the negative first, bring the negative 1 down and do all that. However, I see people doing this, which again is not wrong, it's just a lot of work. What am I doing?
X.
Thank you.
So it's negative 4x squared.
Bottom, bring that up to, no, that would be 4. That's a 1.
No, it's an x.
No, it's a 1.
It's a 1?
It's a 1. Derivative of x is 1. Yeah. Quotient rule, not needed. Now, why did I bring this up? Well, because it keeps happening, and it's relevant in this problem. Does the 4 matter? It does in the final answer, but it's not going to affect the outcome of the integral, so I'm just going to rewrite it this way. Okay, my little rant before, with this example, you see what I'm talking about. If I hadn't told you or given you those trig identities on the previous screen, you would have to approach this integral using a couple different methods. You could try a UDU, make u equal to x squared, see where that gets you. Make u equal to 1 plus x squared, see where that gets you. And the problem is things won't cancel. So you end up with x's and u's. So then you have to recognize that as being an inverse trig function. Which one? I, or I. I, correct. What's A? 1. What's U? X. Just X. Okay. Now, in this particular case, since U is equal to X, we don't need to do a UDU. It's just a plug and chug. Any other situation, if that value for U is not just X, then you need to do a UDU. So a lot of you are doing these problems and and you can't figure out where did that 1/2 come from? Where did that 1/3 come from? That's because it has to be done as a UDU. Now, you could argue, oh wait, this is a UDU, U is equal to X. And hopefully you all realize how silly that is, yes?
Yeah.
Okay. 4 times what?
1/1. Tangent, inverse tangent. 1/x.
X over 1. Yeah. Yeah, it's a definite integral. Are you going to write 1/1? Probably not. Are you going to write x over 1? Probably not. Okay, you're all bright enough to see that that's not going to be the case. Okay, 4 times. What's the inverse tangent of 1?
0.
Nope. Pi over 4. What's the inverse tangent of 0? Where on the unit circle is the tangent equal to 0? 0. So we get a final answer of pi. Okay? Good so far? I got one more example for you. I, or I. It's I, correct. And if that's I, what's U?
E.
No.
1.
No.
E to the 4x.
No.
E to the 2x.
E to the 2x. Very good. Now that doesn't quite fit into the model that we have for the first one, but it will work itself out when we realize that since U is not just plain old X, I have to do a UDU. Also, do you all realize that these two things are equivalent?
Yeah.
Yeah? Everybody, we're good? Okay, so therefore, in this problem, U is equal to e to the 2x. And therefore, du, what's the derivative of e to the 2x? 2e to the 2x. Good. Does that make me happy?
Yeah.
Yeah, because now we can do some canceling. Whoopsh, whoopsh. This becomes 1/2. I'm going to slap the 1/2 out in front because it doesn't matter. And this becomes 1 over the square root of 1 minus u squared du, which fits perfectly with the first formula. And at some point you're going to know that formula off the top of your head, but right now it would be the inverse sine of u over a, which is 1, and in this case, it's a plus c because it's an indefinite interval. So as I mentioned, what's going to happen is a lot of you are going to not know where that 1/2 came from, and that 1/2, once again, comes from this business here. Anytime that u is something other than x, you must do a u du with integrals, not with derivatives. Remember, derivatives don't have u's in them, or shouldn't have u du problems, I mean. Okie doke? We good? Again, it's not very exciting. It's honestly not that important, but it is something we need to cover. Okay.